You know that satisfying snap when you put a magnet on your fridge? Or how a paperclip holder just holds the paperclips? It's like magic, right? Well, we see this invisible force at work all the time. But what's really going on behind the scenes? Let's dive in and pull back the curtain on the amazing hidden world of magnets. Okay, so picture this. You're at a junkyard. There's this huge crane, and it's swinging over a giant pile of scrap metal and old cars. It lowers this massive solid block. And get this, there are no claws, no hooks, nothing. And then, when it lifts back up, tons of metal junk are just stuck to it, completely defying gravity. It looks like some kind of magic. So what in the world is going on here? How is that even possible? That right there, that's the big puzzle we're going to solve today. Now, the short answer is, of course, a magnet. But trust me, the story of how we figured this all out is way cooler than you might think. All right, to really get what's happening with that crane, we have to travel back in time. And I mean way back, long before we had giant electromagnets and all that stuff. Believe it or not, our first run-in with this mysterious force was a total accident. So let's see where the story begins. So our story kicks off in ancient Greece with a shepherd named Magnus. He's out there with his flock, and he's got his trusty staff to help guide the sheep. Now here's the important part for our story. The very tip of his staff had a little piece of iron on it. One afternoon, he's up on the mountainside, and he just rests his staff against this big, dark-looking rock. A little while later, he goes to pick it up, and, it's stuck. Like, really stuck. He has to give it a good hard yank to get it free. And he's thinking, well, that's never happened before. And the feeling was just weird. It wasn't like it was just wedged in a crack. It seriously felt like the rock itself was pulling on his staff. And right there, that moment, that was probably the very first time anyone had ever really noticed this strange, invisible force we now call magnetism. So that strange rock eventually got a name, magnetite. People aren't totally sure if it was named after our shepherd, Magnus, or maybe the area where he found it, which was called Magnesia. But either way, this was it. This was humanity's first introduction to what we call natural magnets, these special rocks that just have this built-in, mysterious ability to pull on iron. Okay, so Magnus figured out that this rock attracts iron, but that makes you wonder, right? Does it attract, well, everything? I mean, that's the next logical question, and you can bet early scientists were asking the same thing. So let's do a little investigation of our own. All right, let's say we grab a few things. We've got an iron ball. Yep, it sticks right to the magnet. Okay, how about a plastic ruler? Nope, nothing happens. A leather shoe? Still nothing. You see the pattern here, right? The big takeaway is that magnets are actually pretty picky. And this brings us to a really important idea. The stuff that is attracted to a magnet, we call those magnetic materials. And really, when you're talking about strong attraction, you're talking about three main elements: iron, nickel, and cobalt. Pretty much everything else you can think of, wood, plastic, your leather shoe, that's all non-magnetic. So now we know what magnets like to attract. But what happens when you get two magnets together? Well, it turns out they have their own secret code, a really strict set of rules about pushing and pulling. Check this out. If you take a regular bar magnet and you sprinkle some iron filings on it, something really cool happens. The filings don't just stick everywhere evenly. Nope, they all bunch up in these two thick clusters, right at the very ends of the magnet. So, these two ends, that's where the magnetic force is the strongest. And these ends have a special name. We call them the poles. And here's a fun fact. Every single magnet, I don't care how big or small it is, has two of them, a north pole and a south pole. That's where all the magic, all the action really happens. And this is where we get to the absolute number one rule of the magnet secret code. It's super simple. Like poles repel. So if you try to push two north poles together or two south poles together, you'll feel them literally push each other away. You can't make them touch. But opposite poles attract. Bring a north pole near a south pole and, snap, they'll pull right together. Now this whole opposites attract likes repel thing, it's not just a neat little trick. This one simple property led to one of the most important inventions in all of human history. Seriously, let's see how this little rule changed the entire world. there's this amazing legend about an ancient Chinese emperor named Hong Ti. The story goes that he had this incredible chariot, and on top of it was a statue of a person. And no matter which way the chariot turned, the statue's arm would always, like magic, swing around to point directly south.
So how on earth did he do that? Well, it's not magic, it's magnets. It's because of another really cool property. If you hang a magnet so it can spin around freely, it will always stop spinning in a perfect north-south line, every single time. So that emperor's statue, you can bet it had a magnet hidden inside.
And that exact idea is what's behind the compass. I mean, that's all a compass is. It's just a tiny, lightweight magnet, the needle that's allowed to spin freely. It lines itself up with the Earth's huge magnetic field, points north and south, and boom, suddenly people could navigate the entire planet.
Okay, so we've covered the history, we've covered the science. How about we get our hands dirty? You don't need to go find a magical rock on a mountain in Greece. You can actually make your very own magnet right now.
It's actually super easy. Here's what you do. Grab a piece of iron, like a regular old nail, then take a bar magnet. You're going to place one end of the magnet on the nail and stroke it all the way to the other end. Now this is key. Lift the magnet up, bring it back to the start, and do the exact same stroke again, always in the same direction. Do that about 30 or 40 times, and believe it or not, you've just turned that nail into a magnet. But a quick word of caution, magnets might seem tough, but they can actually lose their magnetic powers. If you heat them up, smash them with a hammer, or drop them over and over again, you can basically mess up their special properties. Oh, and this is also why you've got to be careful. You should always keep strong magnets away from things like your phone, your TV, or your computer. So there you have it. We went from a simple shepherd's stick all the way to that giant crane in the junkyard, and even the compass that literally let us explore the entire globe. It's pretty amazing how this invisible force has completely shaped our history. So it makes you wonder, doesn't it? As we get even better at understanding and using magnets, what incredible new things will they help us discover next?